Okay, in this video I'm going to show you synthetic division. It's not something you have to use. You can always use polynomial long division. Synthetic division works some of the times in place of polynomial long division. Some people prefer it. It's nice for finding roots because when we see a root on our calculator, that's a situation where we can use synthetic division to divide it out. Again, you don't have to use it. You can always use polynomial long division. Polynomial long division is actually a little nicer because you can take out more than one root at a time. But with synthetic division, you can only take out one at a time. So I'll show you how synthetic division works, and then I'll do some more examples of finding roots, just so you have some more examples to watch me do. Okay, so we're going to start off the same way we usually do. We're going to graph it. Oops, I forgot the 5 in there. 25x to the fourth minus 40x cubed minus 19x squared minus 2x. Okay, and then we're going to look for some roots. My possible rational roots. Okay, factors of this will be my p. So p, I'm going to have either 1 or 2. For q, I'll have either 1, 5, or 25. So that means if I want to possibly see all my roots, I'm going to have my change in x go up by 1/25th. So first let's just graph it and see where my roots appear to be. I should have a total of 4 roots, but maybe not all of them are going to show up here. So I'm going to zoom fit just to have it set my x. So that sets my x for me. And then I just want to see what's happening around 0. So I'll just look from -3 up to 3. See how many times it's crossing 0. Looks like just 2. So that means 2 of my zeros must be imaginary. So let's see if we can figure out what these 2 are that are showing up here. So for that, I'm going to go to my table. I'm going to start at, let's see, I want to go from -1 up to maybe 3. So let's start at -1. And we're going to go up by a 25th. Check out my table here and start looking for zeros. So there's one. -0.2, which would be -1/5. So that's one of them. So write that one down. Keep looking here. Oh, there's another one at 0. Okay, and that one should have been kind of obvious anyways, because I've got an x factor in all of these. So if I take an x out, that's where I'd get the 0. And I think I saw another one. Oh, there's the other one, 2. So I found 3 of my 4. So I'm going to want to divide these out to see where the last one is. So I'm going to, let's factor out that x first. I'm going to get rid of my calculator here. So I'm going to factor an x out of this. Okay, so this is what I'm going to be dividing by. For synthetic division, we're only going to look at the coefficients here. So I'm just going to list them out. Okay, and then we're going to come out and make an upside down divide bar. I'm going to divide this root out. So let's, I've already taken the 0 out, so let's do an easy one first. Let's do 2. So I'm taking that root out. First step in synthetic division, you always drop this first number down. And then you're going to multiply 2 by 25, which gives you 50. You add these, which gives you 10. Multiply these now. 2 times 10 is 20. Add these, you get 1. 2 times 1 is 2. Add these, you get 0. Okay, this is where your remainder is. So as long as you're getting a 0 here, that lets you know that, yes, it is indeed a root, which I knew it would be. So if I didn't get a 0 here, I did something wrong in my division. Okay, now if I wanted to transform this back into a polynomial, this would be the remainder. So this would be my constant term. This would be my x term. And this would be my x squared. Okay, I don't need to do that because I'm going to divide another one out. So I can just add on here and do another synthetic division. So drop the 25, multiply these, that gives me -5. Add these, I get 5. Multiply these, I get -1. Add these, I get 0. So that means this is what's left over. So this would be my constant term, okay, because this is my remainder. So remainder, constant, x to the 1. So I have 25x plus 5. If I set this equal to 0, I'll get my last root. Okay, and it turns out it's one of the ones I already had. So that means this is a multiplicity of 2. Right there at -1/5. So let's look back at my graph again. And I'm going to zoom in on that -1/5 here. So I'm going to change my window so I don't have so many x's. I just want to go from -0.5 up to 0. Okay, so if you see, it's kind of hard to see. Let's change our y values so they're not so big. Let's go from -0.2 up to 0.5. We'll have our changes go by 0.1. So there you can kind of see it. Okay, this is where -1/5 is. Multiplicity 2 means it's going to hit that and bounce up and then come back over and hit the 0 that my other root was. Okay, the 0. So that's what multiplicity 2 does. Multiplicity 4 would do the same thing. 6, all the even ones are going to make it bounce. And the odd multiplicities, it's still going to go through, but it's going to kind of hesitate there. So I found all my zeros, okay? I've got 2 represented here, okay, because my factors now, if I wrote the factored form of this, my factored form would be x plus 1/5, and I would have 2 of those. And then I've got the x minus 2, since 2 is a root, and then I've got just the x. So now I've got all 4 zeros. 2 of them are -1/5, 1 is 2, and 1 is 0. So that's how synthetic division works, and you guys are welcome to use this whenever you want. The only problem with it is okay, it can only be used to take out factors like x plus some number or x minus some number. If I have, 3x minus 7, I can't use synthetic division to divide that out unless I turn this into what it would represent as one of these. So in order to do that, you can set it equal to 0. Okay, the root I would get from this would be 7/3. So I could turn this into x minus 7/3, and then I could use synthetic division with negative, well, it'd be 7/3 outside here. So you're still switching the sign to write down what you hear if you're getting your number from your factor, but if you're using your root goes directly out here. So I'll do another one. I'll use synthetic division again, and then I'll show you an example of one with polynomial long division, so you guys have a couple more examples. So right here I can see that I can take an x out again. So I'm going to do that. Okay, so I already know that one of my zeros is going to be 0. So now I'm going to graph the other one. First, I guess I could look to see if I can factor it. Right? This one I could actually factor by grouping. So I might as well do that. Because here, out of this group, I can take out an x squared. That's going to leave 2x minus 1. Here I can take out a negative 9. Okay, and that's going to leave me with 2x minus 1 also. So this turns into x squared minus 9 and 2x minus 1. This x is coming from there. So now my factors are going to be 0. This is going to give me 1/2 as a factor. This is going to give me plus or minus 3. So now I've got 1, 2, 3, 4, all 4 zeros. So that one was pretty easy. Let's try another one here. Okay, this one. This one might factor also, but we'll do it the other way just so you get a good idea. So if I wanted to factor this one, I think I can take 27 out of both of these. It's 135 divided by 27 is going to be 5. So we could factor this by grouping. So I'll just show you what that is, but then we'll do it the other way. So I could take x cubed out of the first one, which leaves me with 3x plus 5. I could take 27 out of the next one, which leaves me with 3x plus 5. So then I get 3x plus 5 times x cubed plus 27. This is our special pattern. This is a sum of cubes. So that's going to turn into x plus 3 and x squared minus 3x plus 9. So I'm going to have factors of okay, so minus the 5 divided by 3, I get negative 5/3. This one would give me negative 3. This one, I'm going to have to use my quadratic formula on. So I'm going to take negative b, it's going to be positive 3 plus or minus the square root of b squared, which would be 9, minus 4 times a, which is 1, times c, which is 9, divided by 2a, which is just 2. 4 times 9 is 36. 9 minus 36 is negative, and I can't square root a negative, so these turn out to be imaginary answers. So this is actually a good preview into what we're going to be doing when we start finding all roots. So we're actually going to calculate what these negative ones would be. Something you guys should remember from Algebra 2 is how to find the square root of negative numbers. So I'll just finish this one out. So I've got 9 minus 36, which is negative, I'm blanking here, negative 27. Divided by 2. I'm going to break that down. So the square root of a negative turns into an I. 27 factors into 9 times 3 and 3, 3. So I got a pair of 3, so that comes out the I comes out, this 3 stays in. So I've got 3 plus or minus that over 2. So then we're actually going to want to turn these into separate fractions. So it's 3 halves plus or minus 3 halves I squared of 3. Those would be our 2 imaginary roots. So those would be 2, 3, 4. Total 4 roots. So that means if I was doing this by graphing, let's zoom standard. Okay, I'd see 2 there. I would see that my possible denominators are 1 and 3, so I want to see whole numbers and thirds. And my roots are going from -4 up, so I'm going to have my table start at -4 and go up by a third. Okay, then I would see that there's one at -3, which I found when I factored also, but -3, and the other one is -1 and 2/3, which is -5/3. So I would divide those out. So let's do this one with long division, so that way I can divide both of them out in one shot. So I'm just going to move this down so I can have some room to work here. So the 2 that I see on here are, I'm going to be dividing out x plus 3 and x plus 5/3. So if I want to divide these both out at once, I'm going to do x squared plus 5/3 plus 3x. So 5/3 x plus 3x. And then this turns out to be plus 5. So 5/3 plus 3 whole things. This would be 9/3. I'm going to get 14/3. Okay, and I know most of you right there are not going to want to do this because you see the fraction in there. There's really nothing wrong with having that fraction in there. So at this point, if you wanted to do synthetic division, you could. I'll show you how to do it with long division. So I need to match the 3x to the 4th, so I'm going to multiply by 3x squared. That's going to give me 3x to the 4th. Okay, if I multiply here, the 3's are going to cancel, leave me with just 14 x cubed. And then I'm going to have 15 x squared. So then I'm subtracting, so I switch all my signs. Now these cancel. This turns out to be -9. Notice these are x squareds and these are x's, so I'm not going to combine those. I'm just going to bring this down. And then bring the 81x down. So now I need to match that, so I'm going to multiply by -9x. Okay, that 9 will cancel the 3 and make it 14 times 3, which is 42. So it's going to be -42x squared. And then I'm going to have minus 45x. Switch all my signs. These cancel. This turns into positive 27x squared. And this turns into 126x. Bring the 135 down. I need to match the 27. So I multiply by 27. One of the 3's from here, right? Because this is 3 times 3 times 3. So one of those 3's will cancel that and leave me with 14 times 9, which is 126. So that matches. That's good. And this is 135. Okay, so these all cancel and I get a remainder of 0, which is good because I should, because this is a combination of two factors. So I've got this left, 3x squared minus 9x plus 27. So at this point we could try to factor, but since I already know it's not going to factor because this is going to give me imaginary roots, I'm not going to do that. I'm going to show you another way you can do it, since I've already shown you how to do it with the quadratic. Okay, so this is basically what I have, right? Because if I set what I've got now equal to 0, I could divide everything by a 3. I can still do that to make it a little easier. Okay, but now instead of using a quadratic, I'm going to complete the square, just to give you another way to do it. So to complete the square, I'm going to take negative 1/2 and square it. So 1/2 squared is 2.25, which is 9/4, okay, as a fraction. So I'm going to do x minus, or x squared minus 3x. I need this to be 9/4, so I'm going to add the 9/4 on. I'm going to subtract it away, and I've still got the plus 9 that was there before. These 3 turn into my completed square. So that's 1.5. Okay, so that turns into this. These two will come together. So I have 9 plus negative 9/4. This fraction is 27/4. So there's my completed square. Now I can set this equal to 0 and solve. So subtract the 27/4 over. Okay, square root it. And the square root of this, I can break up. Okay, so that negative is going to give me the I outside. This 27 is going to break down the same way I had it up there, so that's going to turn into 3 squared of 3, and the square root of 4 is just 2. And then I do my plus or minus. And then I need to add the 3/2 over. So I get the same thing that I had up here when I did quadratic. Okay, so that's just another way you can solve. All right, I'm going to save this example for later. I think I've given you guys quite a few options for how you can do this. I'm hoping you can start to see how this is all starting to come together. So synthetic division, some of you might just end up loving that, and that's fine if you want to use it all the time. It can be quicker. Polynomial long division works for everything. You don't have to worry about converting it. Okay, and you can still factor too. So lots of good examples here.